Hello students, in my last video I have taught you what is linearly independent or linearly dependent. Now let's move to the next step, which is the basis and dimension. Very important concept for exam point of view as well as concept wise. So now let us study the basis. Basis is something you can say it represents the whole vector space. It is a face of vector space. That is how you can understand it. Okay. Now mathematically how I define a basis. Suppose VF is a vector space, right? VF is a vector space and B is any subset of vector space V. B is any subset of vector space V. Correct? Then this B is called basis if first point B is linearly independent. Linearly independent means what? If alpha 1, alpha 2 belongs to B and A1, A2 belongs to F, then and alpha 1, A1 plus alpha 2, A2, alpha n, An is equal to 0 implies all AIs are 0. This is the meaning of linearly independent which we practiced in the last video. Second is B spans V or B generates V. Generates V or span V means what? It means that if I take any element of V, the elements of B should have capacity to express that element. So if randomly I pick up any element of V, the elements of V should be able to generate it. That is the meaning of generate. So B has a capability of expressing all the elements of V, right? For example, I gave you a very simple example कि if I select few students from your class and they are going out. So outside when they are going, if someone is asking a question about a student who is sitting in the class, so this group is able to express that student. So this way you can remember, right? So whenever there is a question, usually it comes like this: define basis and dimension and check whether the given set is basis or not. So always write the definition, the number of element. Okay, what is dimension? Dimension is number of elements in B is called dimension. Okay, suppose there are 5 vectors in B, then dimension will be 5. So even if they are not asking the definition, they are just asking the question, always write 2 points in short. B is a basis if first B is linearly independent, second B generates V or B spans V. So there only you will get some marks for defining basis. Okay, now how to do the question, what will be the working procedure? Now before this I will tell you one more thing. Okay, let us first take the one example. Suppose I am giving you B as 2 vectors 1, 0 and 0, 1. I want to prove that this is a basis. The very first thing is I have to prove that it is linearly independent. So what I will do, A 1, 0 plus B 0, 1 is equal to 0. So A, this is A plus 0B is equal to 0 and 0A plus B is equal to 0 implies A is equal to 0, B is equal to 0. Means it is linearly independent. Correct? Now second point, how you prove? Take a random element alpha, let it be x, y, belongs to V. Now this x, y should be, this two elements should be able to generate this element. So what I will say, okay, let it is generating. So x, y is equal to say some constant A 1, 0 plus B 0, 1. So now if I solve it, okay, so my target is there any A and B exist which can do this work? That is what we are searching. So x, y is equal to A, B. So A is equal to X and B is equal to Y. So basically A, X and Y value no, B, A and B value we are searching. If we can get the value, then it works. Otherwise it won't work. Right? Same way I'll take one more example since it is very simple. 1, 0, 0, 1. I'll take one more example. Before that, there is something called standard basis. Okay, now what is this standard basis? Like 1001, it is represented by E1 and E2. This is a standard basis. Same way, if I talk about R3, 100, 010 and 001 represent the standard basis. This is E1, this is E2 and this is E3. So if somebody asks standard basis, you should not get confused. If they say standard basis of R2, means I am talking about this. If they say standard basis of R3, means I am talking about this. Okay, now let me give you one more example. Suppose if I ask you, show that this forms the basis. Okay, now see, let's do the same process again. So first point is linearly independent. So what I'll do, A 1 comma 1 plus B 1 comma minus 1 is equal to 0. So A plus B is equal to 0. See, A plus B is equal to 0. And then this A minus B. A minus B is equal to 0. Now if I add these two equations, what will happen? A is equal to 0. If I subtract, B is equal to 0 implies linearly independent. First part done. Now the second part, what I'll do, I'll say, okay, let there be any alpha belongs to V. This is fixed procedure. Take any alpha from V. Now let this alpha be have this structure. Okay, you can take x1, x2 also. Now, am I able to represent this alpha in terms of these two elements? That is what we have to do. So let I am able to do. So let me take A 1 comma 1 plus B 1 comma minus 1. My target is to get the value of this capital A and capital B. So what I'll get? A plus B is equal to X. A minus B is equal to Y. Now add these two. So A is equal to X plus Y upon 2. Subtract these two. So what you will get? B is equal to X minus Y upon 2. So I got the value of A and B. Means how I can write here? See, I'll write and show you. So I can write X comma Y is equal to X plus Y upon 2 1 comma 1 plus X minus Y upon 2 1 comma minus 1. See, if you open this, you will get xy. That is what is the meaning. Right? So this is how you do the questions. So let's move to the questions and practice few questions. Let's come to this question. Show that S is a basis of vector space V3R. Now how I'll start this? First step, as I said, always write the definition. S is a basis if first S is linearly independent. Second, S generates V. This you make a habit कि you have to write down this. Now come to the first point. Okay, linearly independent. So let A, B and C belongs to F. Okay, then A 110 plus B 010 plus C 011 is equal to 0. Okay, this gives A is equal to 0. Then A plus B plus C is equal to 0. Then third term, C is equal to 0. So if A is 0, C is 0, automatically B is also 0. So A, B, C are 0 implies linearly independent. Now go to the second term. Now for second term, let alpha belongs to V and alpha is equal to say X, Y and Z. So now my target is what? This alpha I should be able to express in terms of given three vectors. So I am able to do. I am taking capital A, B, C so that you will be able to differentiate what exactly I am taking. So A, what is the first element? 1 comma 1 comma 0 plus B 0 comma 1 comma 0 plus C 0 comma 1 comma 1. Correct? So now solve it. First element here is X. Right? So I'll put X is equal to A. That's it. Then second element is Y. So Y is equal to A plus B plus C. Third element is Z. So Z is equal to C. So what is the value of B? B is equal to Y. Okay. B is equal to Y minus A minus C. So minus A, minus X. So now see, X value is what? A value is what? X. C value is what? Z. So I'll substitute it here. Correct? I need the value of A, B, C. So now B value is what? B value is Y minus A. So A is what? X. Minus C. C is what? Z. So now I got the value of capital A, capital B, capital C in terms of X, Y, Z. So if I get these three values, means yes, it generates. That's it. After this, you have to just write, since I got the value of ABC, so it generates. Over. So it is a basis. Understood? Now let's move to the next question. Determine whether the set this is a basis of V3R or not. Now see, here very clearly you have to mention one thing. Okay. Now look at this question. Now, when I write V3R, it means it is a three-dimensional vector space. Always remember, if there is a n-dimensional vector space, then n plus 1 vectors can never be linearly independent. Okay, so if you have a vector space of dimension n, then n plus 1 elements of vector can never be linearly independent and they will always be linearly dependent. So now in this case, it is a three-dimensional vector space, and how many vectors I have? 1, 2, 3 and 4. So definitely these cannot form a linearly independent set. So they are linearly independent, implies it cannot form basis. So you have to remember one very important concept. If this number is 3, more than 3 elements cannot form the basis. Directly you can declare this by giving this statement कि if V and R is any vector space, then n plus 1 vectors are always linearly dependent. Okay, so this question orally you can do. Now go to the next question. Determine 1, 1, 2, 1, 2, 5 and 5, 3, 4 is basis of for V3 or not. Okay. So again write S is the basis if two properties you write. Now let us start with the first property. So A 1, 1, 2 plus B 1, 2, 5 plus C 5, 3, 4 is equal to 0. Correct? Now A plus B plus 5C is equal to 0. A plus 2B plus 3C is equal to 0. 2A plus 5B plus 4C is equal to 0. Now to check linearly independent, you have two options. Either you solve this equation in calculator or you just solve this determinant. Correct? So whatever you prefer, you can solve. So now let me quickly solve the system of equation here. Right? So now I'll go to home and I'll go to equations. Okay. Then I have simultaneous equations. I have 3 unknowns. So I'll put it. So 1, okay, 1, okay, 5, okay. All of you do along with me because in exam you have to do. 0, okay. Then 1, okay. Then 2, okay. Then 3, okay. And then again 0, okay. Then again 2, okay. 5, okay. 4, okay. And 0, okay. And then when you do okay, you have got infinite solution. So the moment you say infinite solution means it is linearly independent, right? So here I got infinite solution and infinite solution. Okay, infinite solution means linearly independent. Same way if you find out the determinant, this will be 0. So if determinant is 0, directly declare it is linearly dependent. And if it is linearly dependent, it cannot form the basis. So definitely this is not a basis. Okay. Now move to the next question. Now look at this question. Okay, in between I'll show you one more question where we will show that it is a basis. So let's do one more question here because both the answers we got this. 1, 2, 3, 3, 1, 0 and minus 2, 1, 3. Now I need to check whether it is a basis or not. So what I'll do, again linearly independent, A plus 3B minus 2c is equal to 0. 2a plus b plus c is equal to 0. 3a plus 0b plus 3c is equal to 0. Again, when you solve, you will get the same result. It is linearly dependent. And also, if you solve the matrix, determinant 1, 3 minus 2, 2, 1, 1, 3, 0, 3. So, this will be equal to 0. The moment it is 0, you can declare that it is linearly dependent and hence it cannot form the basis. Okay. So, now let's move to the next question. Now, read this question properly. Let W be subspace of R to the power 5 spanned by these 5 vectors. Okay, so now this is 5 and 5 vectors, so no issues in that. Find subset of vectors which forms the basis of W. So now what exactly you have to do? You have to find out a subset which will form a basis. So these all 5 are not forming basis. From this we have to form a subset. So please understand this thing very clearly in your mind. If you have vector space of dimension n, the number of vectors in basis cannot be more than n. This is the first rule. And when I talk that there are 5 elements in a basis, means rank of the matrix if I form is 5. That is the concept of rank which you have learned earlier in past. Okay. Now this is another category where I am searching the subset which can form a basis. What is a working method? Always form a matrix. Okay, form a matrix keeping these elements or vectors as rows or columns as per your choice. So 1, 2, minus 1, 3, 4. 2, 4, minus 2, 6, 8. 1, 3, 2, 2, 6. 1, 4, 5, 1, 8. 2, 7, 3, 3, 9. Now, once you form the matrix of this, what you have to do? You reduce it to echelon form and find out the non-zero number of rows. That non-zero rows will form the basis. Okay, that will be the non-zero rows will be the dimension, and those rows will form those non-zero rows will form the basis for it. Okay. So let's work on this echelon form. So what is the working procedure of echelon form? First, pick up this first element. Using this element, make all the remaining elements 0. So what you can apply in R2, you can apply R2 minus 2R1. In R3, you can apply R3 minus R1. In R4, you can apply R4 minus R1. And in R5, you can apply R5 minus 2R1. Correct. So when I apply this operation, what I'll get? Let me write here. Okay. Now see, you can do it orally also, and those who have a problem in doing orally, you write and do. There is no harm in writing. See, suppose if I want to operate this thing. Now what is R2? The second row. This is R2. So I'll write this row. 2, 4, minus 2, 6, 8. Okay. And then minus 2R1. So you should multiply first row. This is R1 by 2 and write it here. So 2, 4, minus 2, 6 and 8. And now you subtract it. So now when you are subtracting, what you are getting? Full row you got 0. If you want to practice more question on echelon form, you can see my videos on rank of a matrix. Definitely you will get there so many questions for practice. So second row became 0. Correct? Now next target is R3 minus R1. So directly also you can subtract. Now see how I am doing. 1 minus 1, 0. 3 minus 2, 1. 2 minus of minus 1, 3. 2 minus 3, minus 1. 6 minus 4, 2. Right? The next operation is R4 minus R1. So 0. 4 minus 2, 2. 5 minus of minus 1, 6. 1 minus 3, minus 2. 8 minus 4, 4. Correct? Now next, R5 minus 2R1. So R5 you write 2, 7, 3, 3, 9. 2R1 means 2, 4, minus 2, 6, 8. Now subtract it. So 0, 3, 5, minus 3, 1. So 0, 3, 5, minus 3 and 1. Correct? Now I got this. Now after this, you should move to the second element, make it 1 and below that 0. But here, your last row is second row is already full complete 0. And if you observe carefully, this row if you multiply by 2, it will become same as this row. Correct? It will become same as this row. Means if I do in R4 minus 2 R3, this row will become 0. So now what I'll do, I'll write down only non-zero rows. So 1, 2, minus 1, 3, 4. Okay. Then I'll write 0, 1, 3, minus 1, 2. And then 0, 3, 5, minus 3, 1. And 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Correct? So now definitely the basis will have 3 or less than 3 element because 2 rows already became 0. Right? Now let us do the next process. So always move diagonally. So from here to here I should move, and now using this, below this I should make all 0. So only this is a target. So in R3 I will do R3 minus 3 R2. Correct? So let me see what I am getting. So 1, 2, minus 1, 3, 4, 0, 1, 3, minus 1, 2, and then 0. Now apply this R3 minus 3 R2, 0. 5 minus 9. So it is minus 4. Minus 3 plus 3, 0. 1 minus 6 minus 5. Correct? So this became 0. Now you should move diagonally to this number, and below that I should make 0. So it's already 0. So after this now I have no option to do. So definitely the dimension is 3 because I have 3 non-zero rows. Now corresponding to these 3 non-zero rows, what were my vectors? My first vector was 1, 2, minus 1, 3 and 4. So this is the first vector of my basis. Now second vector is 0, 1, 3, minus 1, 2. Okay, so this came from the third row basically. So the third vector was 1, 3, 2, 2, 6. So that is another part in basis. 1, 3, what was that? 1, 3, 2, 2, 6. Right? And third one, which one remains non-zero is this row. So this row came from the last row if you observe. So the last row was what? 2, 7, 3, 3, 9. 2, 7, 3, 3, 9. So these three vectors forms the subset which makes the basis for this vector space. So whenever they ask you a subset which makes a basis, make a matrix out of it, reduce it to echelon form, count the number of non-zero rows that become dimension, and check what are the non-zero rows corresponding to that, what was the initial vector you took. That forms the basis. Understood? So very simple concept. Let's move to the next one. Okay. Find dimension and basis of the subspace spanned by this. Again the same thing. Okay. Now what you do? Make a matrix. And in the beginning only smartly you pick up the vector which has 1 in the first number so that you can place it on the first number. Okay. Then remaining you can place and prefer to place the zeros at the end. So 2, minus 3, 1, 3, 0, 1 and 0, 2, 1. And you should remember the order because that non-zero rows vector corresponding to non-zero rows only will be there in the basis. Now using this, make all the elements below this as 0. So what I will be doing in R2, I will apply R2 minus R1. Sorry. In R2, I will apply minus 2R1. In R3, I will apply R3 minus 3R1. Okay. 1, 1, 1. Okay. So 2 minus 3, 1. 2, 2, 2. 0 minus 3 minus 2 is minus 5. 1 minus 2 is minus 1. So 0 minus 5 minus 1. Since I can multiply it by 1, so I will do this. So that minus sign will be removed. Then 3, 0, 1 minus 3R1. So 3, 3, 3. So 0 minus 3 minus 2. 0 minus 3 minus 2. 0, 2, 1. Okay, so first target is achieved. Keep below this one all are 0. Now move diagonally. Now I have 5, but I want 1 here. Now since you have the calculator, so you should not be scared of the fractions. Right? So 1, 1, 1, 0, 1, 1 by 5, 0, 1, 2 by 3, 0, 1, 1 by 2. Correct? Now what you should do? Come to this element. Using this, make these two 0. So how you can make this to 0? In R3 you apply R3 minus R2. In R4 you apply R4 minus R2. Right? So what I will be having? 1, 1, 1, 0, 1, 1 by 5. Now 0, 0 and 2 by 3 minus 1 by 5. So this will become 15 as LCM. And 5 2s are 10. 10 minus 3 is 7 by 15. Correct? Now next. Now 0, 0, 1 by 2 minus 1 by 5. So this will become LCM will become 10. 5 minus 2 is 3 by 10. Correct? And now this is not going to trouble you much. Why it is not going to trouble you? Because see 1, 1, 1, 0, 1, 1 by 5. Now this all are 0 multiplied by 15. What you will get? 0, 0, 7, 0, 0, 3. Correct? Now after this I should move diagonally. So I reach to 7. Now using this 7 I should make this 3 0. So what I will do? I will divide the third row by 7. So this will become 1. And this row also divide by 3. So it will become 1. Now subtract these two. Automatically this will become 0. And you get only these 3 vectors as non-zero rows. Right? So I will say the dimension is 3. And what I will do? I will pick up the vectors because of which it became which correspond to the non-zero rows. So you can easily make it out. 1, 1, 1 is the first one. Then 3, 0, 1 and 0, 2, 1. So these 3 vectors form the subset which is a basis. Okay. Now move to the next one. Let S be the subspace of V3R defined by S is equal to this. Find the basis and dimension of S. Now see, this is little different question but very easy question. Let S be the subspace of V3R defined by this. Find the basis and dimension of S. Now what we have to do? There is a vector x1, x2 and x3. And how they are connected? Their relation is x1 plus x2 plus x3 is equal to 0. So can I write this x3 as minus x1 minus x2? Yes, of course I can write. So now if this is a element alpha, I can rewrite alpha as x1 comma x2 comma minus x1 minus x2. In place of x3 I have written this. Okay. Now can I split it like this? x1 comma 0 comma minus x1 plus 0 comma x2 comma minus x2. Now this can be written as x1 1 comma 0 comma minus 1 plus x2 0 comma 1 comma minus 1. Right? So I can say that 1 comma 0 comma minus 1 and 0 comma 1 comma minus 1, these two elements forms the basis. And also if you check, they are linearly independent. Right? They are linearly independent, and also I am able to express this element as a linear combination of these two elements. So they form the basis for this vector space. Okay. So let's move to the next question. Now S is a subspace generated by this. Find the basis and dimension. So again the same thing you have to do. You have to make the matrix of this. 1, minus 2, 5, minus 3. Okay. Then next 2, 3, 1 minus 4, 3, 8 minus 3 minus 5. Correct? So S is a subspace generated by this. Find the basis. So what you will be doing now? Again convert this to the echelon form. And when you convert this to echelon form, you will get the answer. So using this one, make these two elements 0 first. Okay. So see what I have done. This was a matrix. First I applied as usual. Using this, make these two 0. So for that I applied these two operations and I got this result. Now I can easily make it out. If I multiply second row by 2, I'll get the third row. So what I did in the third row, I divided it by 2. So this will become 7 minus 9 and 2. And then I subtracted these two rows. So I got third one as 0. Right? The moment you got third one as 0, I will say that these two forms the basis. So dimension is 2 and corresponding to these, whatever the first two vectors are there, they will form the basis. Right? So this is a very simple form to work out. Now look at this one. This also you don't have to struggle too much. You have to just prove it, right? See now, in this question, if you work by the normal process, it becomes little complicated. If V is a vector space of ordered pairs of complex number over R, then show that it is a basis. So first, linearly independent is so very easy. A1 1 comma 0 plus B1 I comma 0, A2 because more numbers, so ABCD I am not taking, plus A3 0 comma 1 plus A4 0 comma I is equal to 0. So now see, A1 plus I A2 is equal to 0. Okay. Now second, A1 0, A2 0 and A3 plus I A4 is equal to 0. Now when I talk about complex numbers, 0 means 0 plus 0i. Here also 0 plus 0i. Now when you compare how two complex number are equal, when real part is equal to real part, means A1 is equal to 0, imaginary part is equal to imaginary part. So A2 is also 0, A3 is 0, A4 is 0. Since all constants are 0, therefore it is linearly independent. Now when I say that it generates, so what you take, any number alpha you take. Now this alpha is nothing but some complex number a plus ib. Okay, so you should be able to write this a plus ib in terms of these four vectors. Correct? You should be able to write this as these four. Okay, so alpha is a C plus ID. It will be odd pair, right? It will be ordered pair because they have given ordered pair of complex number. So basically the real number and imaginary number you can say, right? So I have taken these two numbers like this. Now I should be able to write this in terms of all the terms. See now, A plus IB comma C plus ID. So you have to just rearrange the terms. You need first real number A. So you write A 1 comma 0. This will give you A. Right? Then you need IB. Right? So wherever I is in the second one, you write it like plus B of 0 comma I. Right? And then comma you can write as C I comma 0, 0 comma I 1 and plus D of I comma 0. See here how I am arranging the term. First I wrote like this, but if I write like this, this is not giving me this vector. So I cancelled this approach. Then I wrote it like this. Now see, if I solve this, this will give me A plus IB comma C plus ID. So this is a combination. So basically I took a number element vector and I was able to express it in terms of these four numbers. So again it forms a vector space. Okay. So let's move to the next question. Show that this forms the basis. I think we have done this question. Again, let us try to do A 1 comma 2 comma 1 plus B 2 comma 1 comma 0 plus C 1 comma minus 1 comma 2 is equal to 0. So A plus 2B plus C is equal to 0. 2A plus B minus C is equal to 0. A plus 0B plus 2C is equal to 0. Right? I am feeling I have done this question. Let me check. Yes. No. This is different. First two vectors are same. Okay. No issues. Let us do it quickly. Instead of leaving it, let us finish it off if it came. Okay. So now see, I have this. Let me solve these three equations, or you can solve the determinant. Whatever you feel is easy for you, that you should do. Okay. So I went to simultaneous equation. I have three unknowns, so I picked up three unknowns. So 1, okay, 2, okay, 1, okay, 0 okay, 2 okay, 1 okay, minus 1 okay, 1 okay, 0 okay, 2 okay, 0 okay. Now again okay when I am doing, x value I got, 0, y value and z value also I got. The moment I get the values of a, b, c means it is linearly dependent, and the moment I get that it is linearly dependent, I can directly say it is not a basis. Okay, this you solve it, I solve it again. It is giving me 0 or 1 2 1, 2 1 minus 1 1 0 2. The determinant value is minus 32, which is not equal to 0. So this is linearly independent, right? This is linearly independent, and same way now you can take alpha and say that it will generate. So this forms a basis. Now I hope you understood how to show that it is a basis or not. Now the next topic which we are going to discuss will be orthogonal and orthonormal basis, which is very important and very simple concept. Only one additional line you have to do whatever we have done now, and that topic will be over. So my next video will be based on that. So please like, share and subscribe the channel, so that the moment I will upload a new video, you will get the notification. And if you feel that this channel is really helping you, then I need more and more subscribers. So I hope you will like it. Thank you.